Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In recent years, an incredible development has transpired in the space sciences. Mainstream astronomical literature now rather routinely acknowledges the existence of electric currents in space. But the question is, how significant a role do these electric currents play in the dynamics of the universe? In our most recent space news, we reported on the discovery of a radio-emitting plasma filament, which connects two galaxy clusters. If electric currents connect celestial objects at such vast cosmic distances, as plasma cosmologists have proposed for decades, then how might we also detect electric currents in our own celestial neighborhood? Today, physicist Eugene Begashev and several colleagues are attempting to answer this question through a detailed analysis of the conditions near our solar system. In part 3 of this 4-part presentation, Eugene continues his discussion on the evidence for plasma currents connecting our solar system with the nearby interstellar environment.
Let's examine some other evidence that the local interstellar chimney structure where our solar system is situated represents a large-scale plasma filament. One of the interesting pieces of evidence is the existence of the so-called Gould belt, the belt of bright stars, molecular clouds, and star-forming regions encircling the Sun at an average distance of about 1,000 light-years and having a thickness of about 200 light-years. Perhaps the most fascinating feature of that belt, if we look at it in galactic coordinates, is that it doesn't quite coincide with the galactic equator, that is, the galactic disk, but is tilted with respect to it to an angle of 18 degrees or about so. In galactic coordinates, it makes it look like a sine wave with an amplitude of 18 degrees. This structure seems to be the largest of such sort in our vicinity, so it's not entirely clear how it came to be and why is it tilted that way. But as we've previously seen, the local chimney is also not strictly perpendicular to the galactic plane, but slightly tilted. And if we compare the relative positions of the Gould belt and the local chimney, it would become clear that the belt sort of wraps around the chimney and is most likely related to it rather than the larger structure of the galaxy itself. Moreover, the whole structure of the chimney plus the Gould belt around it would immediately start to resemble the famous squatter man figure, a typical shape produced by the plasma discharge. We see a current column in the center that widens at the bigger distances up and down from the center, and we see the torus around it, represented by the Gould belt. Take another look at this picture and you'll see what I mean. The characteristic circles are there on both sides of the chimney. In my opinion, it is highly unlikely that such a configuration was produced by some chaotic gravitational interactions. Moreover, another prominent structure, the so-called Lockman hole, coincides with the axis of the local chimney. Lockman hole is defined as a region of a much lower density of neutral hydrogen, so it looks much more transparent in extreme ultraviolet and soft X-ray range, and it doesn't glow as much itself in the infrared. But it might just be the case that the very fact that there is not much neutral material there is only the consequence of a higher ionization. There is a stronger current shooting near the center of the local chimney, so we don't see many neutral atoms along its way. One might also look at the parameter called the interstellar extinction. And it has nothing to do with mass die-offs of species or something. It means the extinction of light, that is, its absorption or scattering by the interstellar dust or atoms. So if we look at both galactic hemispheres, north and south, and measure this parameter across the sky, we see that right near the galactic north and south, perpendicular to the galactic plane, there are quite prominent clearings, represented by the black plumes on this picture. The northern one, which you can see on the left, is exactly the Lockman hole. It's evident that both of them more or less coincide with the galactic north and south, but not quite. They're slightly tilted, just like the chimney axis is. So they represent exactly that, the openings of the tube-like local chimney structure into the space above and below the galactic disk. The existence of these clearings have been quite an asset for the extragalactic astronomy, as they represent the more or less transparent windows into the outer universe. Perhaps another piece of evidence for plasma processes might be various anomalous readings of chemical compositions of stars, both in our vicinity and in the farther cosmos. Again, Pleiades cluster might be a great example, but as some of the papers indicate, the problem seems to persist for stellar clusters in general. The spectral characteristics of even the most typical stars somehow often violate the expectations, and perhaps it might all be tied to their positions with respect to the surrounding filamentary structures. Some works have actually directly stated that the anomalous stellar chemistry might be linked to the larger scale magnetic fields in the corresponding regions. One of the mechanisms of production of these chemical anomalies, as Don Scott himself indicates in one of his papers, might be the so-called Marklund convection, the sorting of the chemical elements in a Birkeland current column according to their ionization potential. In fact, that might be one of the reasons why there is less hydrogen in the center of the local chimney column, just because, according to Marklund, Alfvén, and Scott, hydrogen would prefer to gather at the outermost shells of the chimney, sorted out by the convection in plasma. That way or another, this mechanism definitely deserves a lot of attention with regards to stellar chemistry, and plasma filaments might just be the right tool that the astrophysics was missing so far to explain many of these observed peculiarities. Another evidence for the actual existence of the plasma currents in the local chimney might be represented by the scattering of the radio waves. It has been previously shown that this process, which depends on the properties of the interstellar medium, does not occur homogeneously in the area of the local chimney, which would mean that there are areas of higher and lower plasma density and perhaps current strength. Speaking of current strength, one of the hypotheses in the electric universe is the possible relation of the brightness and temperature of the stars to the current density of the plasma filaments that interact with them. In that regard, I wish to bring up an interesting paper that discusses the changes in measured temperature of the star Arcturus, the brightest star in the northern celestial hemisphere, over the span of several decades. The graph given in this paper is quite astonishing. It almost seems like the temperature of the star was steadily rising over a very short time span, at least in astrophysical terms. I haven't seen any explanations for that according to the current astrophysical models, but in the framework that we're dealing with here, perhaps we might assume that Arcturus was just pretty quickly moving into the area with a higher current density, and therefore its brightness increased. It's not very hard to believe in, as although it's pretty close to us, only some 37 light years or so, its velocity relative to the Sun is very high, some 122 kilometers per second. That's about half of our own speed around the galactic center. Most of the other objects in our vicinity typically have speeds of maybe tens of kilometers per second relative to us. That is not the only example of such sort. Perhaps another one might be represented by another very bright star, in this case the brightest star in the whole sky, Sirius. It has been a mystery for quite a long time why the ancient civilizations, including Egyptians, Greeks, and Romans, called Sirius a red star. It is clearly bright blue right now, and couldn't possibly have been red even 2,000 years ago, according to the current stellar models. But perhaps the change in color of Sirius was caused by the same reason as brightening of Arcturus, the shift with respect to the surrounding plasma streams. We might see that on the scales of the local interstellar cloud, Sirius seems to currently occupy a somewhat clearer filamentary area. That might indicate a stronger current in the surroundings and therefore higher temperature of the star. Whereas in ancient times it might have been connected to the local current filaments more poorly and demonstrated a somewhat dimmer red color. Another, perhaps more general consideration that we might take into account concerns the frequency shifts of electromagnetic waves that travel within space plasmas. There has been some debate about the possible intrinsic redshifts of astrophysical objects as promoted by Halton Arp, etc., but there is a possibility that even the regular wave of light might change its frequency when it propagates through plasma. One of the known examples of that effect is the frequency blue shift of laser beams. It is known that under certain conditions, when the electromagnetic wave encounters an area of strong ionization, its frequency might rise quite significantly. Then there is a hypothesis that an inverse process, a redshift, might also occur in certain conditions, say if the plasma is very hot but has a very low density. So it could be seen that a lot of effects that might usually be attributed to, for example, Doppler frequency shift, might theoretically be related to the distribution of various cosmic plasma structures that the light that we observed was traveling through. Jim Wenninger proposed an idea that, for example, the so-called flyby anomalies might be explained through that. A flyby anomaly is an unexpected instantaneous change in speed of a spacecraft that performs a gravitational maneuver near Earth or other planet. At least one other example would be Jupiter. So since the velocity of a spacecraft is measured through Doppler effect, it is quite possible that some similar plasma processes in the vicinity of Earth cause this frequency change and not the actual change in velocity. If all that is correct, this is yet another indication that we need to pay more attention to the distribution of plasmas in the neighborhood of the solar system, the local interstellar cloud, and the local chimney.